right, so hello everybody and welcome back to Tuesday's Open Class. We are today in Open Class number 143 and we are going to be talking about TFs. So last Tuesday we had some issues which have been already solved for today. So today we are going to basically complete this TF Open Class that we left without finishing last Tuesday. So yeah, that's the purpose for today. We are going to overview a little bit about TF, and we are going to take a more close look on how to broadcast a TF, a dynamic TF in this case, using a Python script. So yeah, basically that's it for today. So let's go for it. Welcome everybody, and I'm going to switch right now to my computer screen to make sure that everything is fine, is going well. So let me have a look here. There we go. So let me go to the workshops section where we should have the streaming going on here. Perfect. So yeah, let me know here in the chat, please, if everything is fine, sound is fine, video is fine, so that I don't have to worry about anything but doing the class. And as always, the first thing that you have to do is to click on this button here, which says fork and open the class rosject, okay? So I'm going to click here myself right now. And this basically what's going to do is to create a copy of the rosject that we are going to be using today. It's going to create a copy in your area, in your account, and it's going to automatically open it, as you can see in my case, which the rosject is being here opened. So so yeah, please go ahead and all of you click on this button so that you can get the rosject. And then it's going to take some seconds here to fully load everything. As you can see, you have here in the right side the streaming panel with the live stream. You have also the chat in case you want to comment anything, so that I'm going to be seeing your comments. In case you have questions, feedback, whatever, you can write it here in the chat. And yeah, so let's now wait for some seconds until my rosject gets loaded. And meanwhile, I want to talk to you about today's class. So today's class, we are going to be doing TF, but TF is a very big subject, a very big topic. So obviously it's impossible to cover everything in 1 hour class. So so yeah, today I'm going to be focusing on broadcasting a dynamic TF, okay? And also a little bit on how to debug TF related issues. You will see in a moment. But yeah, so this class is part of course of well, I am doing this class based on a course that we have recently published in our academy, the full TF course. So let me open here a different tab where I'm going to show this. So yeah, we recently published it. In fact, it was published last week, the TF course for ROS2. Okay, so I'm leaving links of all these here in the notebook. You will see in a moment. But yeah, so here you have the whole complete TF course for ROS2. Okay, important also, in case that you don't know, that we are going to be working on ROS2 today. Okay, no ROS1, but ROS2. So yeah, in case you want to learn more about TFs or different subjects, how to subscribe, how to listen to TF, what is the Robotics state publisher, what it does, what relation it has with TFs, etc. So everything you're going to find it here in the TF for ROS2 course in our academy. Okay, so let me now come back here to the rosject. So as you can see, the notebook is going to be automatically opened, like you can see here in my case. So just some quick requirements in case that you are new to open classes. So bear in mind that you should have some basic knowledge of Linux, how to move through a terminal, basic commands, etc. it would be good for this class to have ROS2 basic knowledge, for instance, how to create a package, etc., but it's not mandatory, okay? And as always, I leave here as well the complete course, because the one that I have just shown to you. So you have links here for all these, for the complete course, for the requirements, etc. Okay, which is going to take you to the full TF course. All right. Then, yeah, so with the proper introductions being made, I think that we are ready to start. So far, so good. Let me know here in the chat, have you been able to copy properly the rosject to your workspace? Have you opened already the rosject? You have the notebook here. You can see the notebook. Yes, no, everything is fine. Okay, I don't see any comments so far, so I'm going to assume that everything is going fine, right? Okay, then, yeah, so the first thing that we are going to do is to launch a Gazebo simulation. Okay, so we are going to be working on a Gazebo simulation. So this is the first step that we are going to do. So for this, we are going to open a new web shell, a new terminal, a new shell, by clicking on this icon that you can see here in the image, which you have down here. It's the first one. So if you click here, this is going to open, as you can see, a new terminal, regular Linux terminal, where you can type commands, etc. And then here we are going to run the following two commands, okay? So what I recommend is that you copy them directly from the notebook, like this, with Control-C, or however you want, and then paste them here to the terminal to go faster. So first command, we are running a regular CD in order to go to this folder, this SRC folder. And now we are going to run this script here, which is named start turtle cambot sim no tfs.sh. So let's run this script. I can show you now in a moment the contents of this script. It's very simple. But yeah, so the first time that you start a simulation, you might have some issues with Gazebo, which are normal, okay? Let's see if I have them also or not. So yeah, here I'm starting to get the output. And in some cases, Gazebo might crash the first time that you launch it. Yeah, here we are, okay? So you might also be getting this error message here with related to the spawn entity service from Gazebo, which says that it's not available, okay? Don't worry, this can happen the first time that you launch the simulation. So don't worry, I'm going to leave it like this also so that you can see how to proceed. So, so I'm going to wait a little bit until Gazebo client loads, which should be in a moment. There we go. So here Gazebo client has opened, and now probably I'm going to get an empty world with nothing. Yeah, so here it's loading the client. Yeah, okay, so I have the world, but with no robots spawned, okay? So in case that you see, you get something like this, with this world with no robots on it, then very likely it's because you got also this error with the spawn entity service unavailable, okay? In this case, what you should do is very simple. So you just terminate this terminal with Control-C, like I have just done, and then you just relaunch it, okay? So now the second time that you launch it is going to work properly, you will see. There we go. So here we are loading the world, and here I have my two robots spawned, okay? So let me make this a little bit bigger so that you can see it. So basically what you should get is something like this, okay? So you have this world which resembles a lot to a beach, okay? It's a beach environment now that we are close to summer. So it's nice to start getting familiar with beaches again. And yeah, so you're going to have here in the sea this turtle model, okay? You can see this 3D turtle model, and then on top of it we have this this yellow sphere, okay? So this is a simplification of the cambot that I have here in the images, okay? So as you can see here in the images, you are going to see this very nice looking cambot. Actually, this is the robot and the full simulation that we are using in the course. But for this open class, I decided to simplify a little bit the cambot because it was too heavy for Gazebo to load the textures and so on. So this is the simplified version of the cambot, okay? This yellow sphere. So yeah, at the end, you should get something like this, okay? So this is the simulation that we are going to be using for today's open class, with the cambot here on top of the turtle. All right? Perfect. So let's keep moving. Then the first thing that we are going to do is to analyze a little bit the simulation in terms of TF. Okay? So what transforms, what TFs is this simulation, are these robots providing? So the first thing that we are going to do for analyzing this is to load RVs. Okay? So let's come back here to our shell, and we are going to leave this one running, okay? Don't close it because this first shell is where we have the simulation running. So if you close it, the simulation is going to die, okay? So let's leave it here running, and then we are going to open a new shell by clicking on this plus icon that we have here. So this is going to open a brand new terminal, as you can see. Then in this new terminal, we are going to run the following two commands. So first, we are going to source here the simulation workspace, yeah, and then we are going to run this command here, which basically, as you can see, what we are doing is to run ROS2 with a predefined configuration file. Okay. Then before running this command, let me open the IDE or the code editor, however you prefer to call it, which is this second icon here, okay? So if you click here, this is going to open the IDE, the code editor, which is going to give you access to all the folders and files of this rosject with a graphical interface, okay, which is always nicer than interacting through the terminal. So, for instance, here you can find this simulation workspace, which if you open it, you can go here inside the SRC folder. Sorry, let me get to the drink. There we go. So, for instance, here inside the simulation workspace and inside the SRC folder, you are going to find the script that we have executed here for starting the simulation. You have it here, the start, turtle, cambot, sim, no TFs, sh. So you can see what this script is doing here. Yeah, so it's basically doing some sources and then running this launch file. Okay, which is inside the Turtle TF 3D ROS2 package, which you can find here. Okay, I'm not going to go into all these details. You can investigate by yourself. Okay, then yeah. So what else? Okay, yeah. Then another thing that you can check is this RV's configuration file that I have provided already here in the rosject. So if you go inside the ROS2 workspace, you're going to see that this file is already here. So we are going to be loading this configuration file, okay? Then, yeah, so let's run this command right now. Okay, so yeah, as you can see, this has opened the graphical tools here, which here in the graphical tools window, you can visualize RVs. This is the ROS2 that we have just launched, okay? So first of all, we can see that some things are not right here for sure. So first of all, we have both the camera bot here in the middle of the turtle, so everything is mixed. The TFs are not quite correct, as you can see. We can also see some errors here with the different robot models related to 3Fs, missing transforms, etc. And also we cannot see the camera images, right? So this camera bot that we have here, it contains a camera, so we should be able to visualize what this camera is capturing, the images that this camera is getting, and we are not, okay? So for sure, by having a quick look at RVs, we can see that there are some things wrong, okay? But we can fix some of them by changing the fixed frame, okay? So we are going to do this right now. We are going to change the fixed frame from world to chassis, okay? Let's select chassis as fixed frame, and then, okay, so some things got fixed. We can now visualize here the cambot. So it's not white. In RVs, whenever you get a robot which is looking white, like we were having a moment ago, probably it's that there is something wrong, okay? So in this case, we are getting the color, which is red in this case, black in this case for RVs. Also, the errors from this robot model are gone. Okay. For the cambot, the robot model is looking okay now. We are not getting transform errors, and also we can now visualize here the images from the camera, right? So we have fixed some things, but still there are some errors. All right. But let's keep advancing a little bit. And yeah, so the first thing that we have done is to change the fixed frame to chassis, okay, which has fixed some of the errors, but for sure not all of them. So another thing that we are going to do is to move a little bit the cambot, okay? So we can do this by running this command that you can find here in the notebook, running this teleop twist keyboard node. So let me select this command, and I'm going to execute this in another new shell. Okay, so I'm going to open a third one. By the way, you can rename here the shells. It's a very nice tool that you can use here. And for instance, if you click here, if you click 2 times, you can rename. And for instance, I'm going to call this shell simulation. This one I'm going to rename it to ROS2. See, so this way you can know, just by looking at the shell, at the terminal name, what is running in each one of them. Okay, so I wanted to show you so that you can use it as well. Then now we are going to run this teleop twist keyboard node here, and this is going to allow you to move the cambot. Okay, so let me show you here by clicking on the terminal keys. They are explained here. Also, you have explained how to control it, how to control the cambot in the notebook, because it's a little bit tricky. Okay, so it's like applying forces to the cambot. Okay, but you'll get used to it. Then let me come back here to the terminal, and let me move a little bit. So I'm going to start moving it forward, as you can see. So I am moving this forward. Then if now I have a look at RVs, I'm going to find something interesting. First is that the images are getting updated. So I can see that the robot is moving forward from the images. But here in the main screen of RVs, nothing is happening. So the robot is not getting away from the turtle. So yeah, some strange things still here. Okay, then let me stop the robot, the cambot, so that I don't lose it. Let me move it a little bit back. Yeah, let me get it back here. By the way, in case that you lose control of the, in case that you lose control of the robot or whatever, don't worry. Okay, it's as easy as relaunching the simulation. Okay, I can do it right here. So in case that you start moving and you lose control of the cambot, don't worry. Just stop the simulation and relaunch it. okay, and then everything is going to go back to the initial position. All right, yeah, so here I have my simulation again. There we go. All right, so yeah, let's go back to a notebook and let's advance a little bit more here. So we have done some initial tests here with RVs to see the current situation. So, but we still need some extra information, right? So we can tell already that some things related to the transforms are not correct in this simulation. So the relation between the robots is not correct, for instance. But one thing that we are going to do right now is to use another very interesting tool, which is the rqttf tree. Okay. So for this, we are going to need to install it. All right. So let's go here to an empty shell, for instance, this one, and we are going to run these two commands. First of all, sudo apt update. We are doing this basically because this program, the rqttf tree, is not installed by default in the system, okay? So we are going to install it very easily here with a simple apt install command. So first we do an apt update, and once it finishes, we are going to run this apt install, and we are going to install this package, ROS galactic rqttf tree. So let's run this command, so that we install now in our rosject this package. And then once it finishes installing, we are going to be able to run this command here, ROS2 run rqttf tree rqttf tree. So let me already select it from here, copy it. This is almost installed. And this TF tree is going to give us a lot of information related to the TFs, okay? So we are going to be able to visualize all the frames and the TFs which are connecting these frames. So it's going to gives us very valuable information related to TFs. So let's run this program, rqttf tree. And once again, in order to visualize the output of this program, we are going to come to the graphical tools, okay? So if we open here the graphical tools, we are going to see the rqttf tree program, okay? Once it finishes loading, there we go. Okay, so let me close this. Yeah, so now here we should, you can maximize it and get closer. So in order to visualize this better, let me get closer to this, if I can. There we go. Yeah, the scroll of my mouse doesn't work very well, as you can see. Okay, let me try to make this bigger here. Please, I want to get closer. Okay. Damn it, this. Okay. Let me use the trackpad instead, which looks like it's working better than the mouse scroll. Yeah. Okay, we are getting there. All right. Yeah, so here I have my TF tree information, okay? Then, yeah, let's leave it like this. So I can see some things here. So first of all, I can see that I have two separate trees. One is for the turtle, and the other one is for the cambot, okay? So my cambot has these frames, the cambot base link, chassis, and the camera link, which are connected through TFs, as you can see. And then I have this other tree, which is not connected at all with the camera bot, which is this tree is the one for the turtle, okay? For the 3D turtle. And it has its base link, turtle chassis, and different frames here, okay? So some data that I can extract from here is that, first of all, the two robots are not connected to each other. There is no transform which connects the two different robots, the turtle and the camera bot, right? And also I don't have any world frame, right? So we are going to try to fix these two issues in the following exercise, okay? Because we should have a common frame that connects both robots, right? Then in order to achieve this, we are going to use a TF broadcaster. So we are going to broadcast a transform, okay? Then let's come back to the notebook and let's go to the practical part, okay? So now we are going to stop analyzing and we are going to start working a little bit, okay? So I want you to do all this with me as well. Then the first thing that we are going to do here is to create a package, a new package, okay? So let's get a shell. We can already close here the TF3. We can already close it, the program. And now what we are going to do is to run these commands in a terminal. So first of all, we are going to go inside the ROS2 workspace SRC folder. Once we are here, we are going to create a new package. So I'm going to copy the command directly from here, paste it, and this command, as you can see, is going to create a new package, ROS2 package create. It's going to create a new package named myTF ROS2 course package, okay, with some dependencies. And if you come to the code editor, for instance, you are going to be able to see this new package that you have just created here. All right? Then, okay, so we are going to create a folder named scripts, as you can see. So let's run this command. And then we are going to create a new Python script, as you can see here, cambot odom to tf pop.py. So we are going to create this new script inside the scripts folder. And we are going to change the permissions of this file to give to the script execution permissions, okay? All right, so I have finished executing all these commands. So now I have my package created here with the scripts folder, and inside this scripts folder I have my Python script here, which right now it's empty, right? Okay, so next thing I'm going to do, let's first fill the empty script with some code, okay? So you have the contents right here in the notebook as well. So I'm going to select all these here from the notebook and copy it and paste it here directly to the script. Perfect. So what do we have here? Okay, let's have a look at this script, because this script is going to broadcast a TF. So let's have a quick look, a quick overview to this script. So we have a class here named cambot odom to tf. All right. Then here in the constructor, we are creating a subscriber, which is going to subscribe to the cambot odom topic, to the odometry of the camera robot. Okay. Also, we are creating here a transform broadcaster, right? Okay, then here we have the definition of the subscriber callback, which is this listener callback function, where basically here what we are doing is to call this function, update data, and call this other function, broadcast new TF. So inside the callback of this cambot odom topic, we are calling those two functions. First, the update data function, and second, the broadcast new TF function. So what do we have here in the update data function? Well, basically in this function, all we are doing is to save the odometry data, which is contained in this MSG variable, as you can see. We are saving the odometry data into this class attribute, cambot odom. Okay? Then we can also have a very quick look here to the broadcast new TF function, which we have down here, broadcast new TF function. So inside this function, we are first of all getting the position and orientation from the odometry data, right? So here we have another function, get odom data, which is defined up here, which basically it's going to extract the position and orientation from the odometry data, which we have in this cambot odom class attribute, right? So we extract the position and orientation. Then here what we are doing is to create, to give values to the transform, right? So we are giving it a timestamp, which is the time now. We are giving it a translation and a rotation or orientation, okay? Then once we have these values, we publish the transform, we send the transform, or we broadcast the transform, however you want to say it, okay? Yes? Then, yeah, so basically, that's it. We have here this init.tf message definition, which actually I think that we are not even using it. Init tf. Oh yeah, we are calling it here in the constructor, as you can see. Yeah, so here in the constructor, we are calling this init.tf message, where we can find the function right here, init.tf message. Basically, this is assigning the frame ID, which is going to be world. The child frame ID, it's going to be the base frame. Yeah, in this case, it's going to be this robot base frame, which is camera bot base link. Okay? So we are going to be broadcasting a transform from the world frame to this camera bot base link. Okay? And yeah, so basically this is what we are doing here in this init.tf message, okay? So we are defining the frames, the parent frame and the child frame of our TF, okay? Yeah, so far so good, makes sense. And then in the main, we are just spinning our node, so that we are going to be publishing this, we are going to be broadcasting this transform until somebody stops this program, right? Okay, then, yeah, so one more thing that we are going to do is to install our script, okay? So we are going to have to compile now and everything. So we are going to add this install function here in the CMake list. So let's open here the CMake list file of our package. And then here at the end of the file, we are going to paste this install function, which basically is going to install the script that we have just created. Okay? All right. So, yeah, we are ready. Then now let's compile. Yeah, so here we have here you have all the explanations of the code. Okay, so in case that you want to see something more in detail, you can have a look here. It's everything explained in the notebook. But basically, it's what I have just explained about the code. Then, yeah, so let's compile now. So let's come here, and we are going to I lost where there we go. Okay, yeah. So let's go to our workspace here, ROS2 workspace. And then let's compile it. Call build symlink install. We are going to use the symlink install tag in this case. So this is going to start compiling. Very well. There we go. So now let's source the workspace as always. And then finally, we are going to run our program, right? So, yeah. So here we have the command that we should run. It is ROS2 run my TF ROS2 course package, so the name of the package and the name of the script that we want to run. Cambot odom to TF pub.py. Okay, so we are going to run our script. This should start publishing this transform from world to, there we go. This should start broadcasting the transform from world to camera bot baselink, right? With the data related to the odometry of the camera bot, which is published into this topic, cambot odom. Okay, so now let's check again RVs, and now we should get something like this, okay? So now we should get something more accurate, which shows the camera bot on top of the turtle and with the TF published here. So let's run again RVs, which I had here. So I'm going to run it one more time and see if I get the same result. Okay, so there it goes. It looks like yes. Okay, so now I am getting the camera bot here on top of the turtle, which is the same as in the simulation, and I can see this transform, which basically, if we mark here the show names, this transform goes from world, which is down here, to the camera base link, right? It goes from this camera bot base link to world, right? If I take out this, see? So you have here the world frame, and up here we have the camera bot base link. Okay, still there's something strange here, right? Because we cannot see the images. Why? So shouldn't we be able to see the images? So there's still something wrong here, okay? So what's going on? Well, we can get some clue of what is happening here in the terminal. So if we come here to the terminal, where we have RVs, we can see this message that is being constantly published, which says, message filter dropping message frame camera bot baselink at time whatever. For reason, the timestamp on the message is earlier than all the data in the transform cache. Okay, so it looks like there could be some kind of error with the timestamp. Yeah, with this timestamp that we are using here in our transform, there could be some kind of error here. So in order to better analyze this, let's just stop everything one more time. Well, no, actually, let's just stop only RVs. So we are going to stop RVs here. And let's open a new shell. We are going to leave here our TF broadcaster program running. And now we are going to use the TF2. Well, we can have a quick look, by the way. Yeah, let's have a look at the new TF Now that we are publishing this, we are broadcasting this new TF, we can run the rqttf tree again, and we are going to see what has changed from the previous scenario. Okay, so let's run it one more time here. Let's come back here to the graphical tools, and now basically we can see that we still have two different trees, one for the turtle and another for the camera. But now this camera bot base link, we can see that it is connected to the world frame. Okay, so our code, our script, what it's doing is to publish this TF basically. Yeah, this TF from world to camera bot base link is the one that it's being broadcasted by our program. Okay? Very well. So let's stop the TF tree now, and we are going to use another tool which is called the TF2 Monitor. This is a very useful tool that can help us analyze the delay between transforms. Okay? Since the error message that we are getting here, it appears to be related with timestamps, so we are going to use this TF2 monitor to monitorize, to get data about the delay between the transforms. So how often are the transforms being published? Then we can do a very quick test, first of all, with this command, ROS2 run TF2 ROS, TF2 monitor, and we are going to check the delay from the transform between camera bot base link and RGB camera link frame. Okay, so let's have a look at, let's run this command here. We can run it right here, for instance. Gathering data, so it's gathering data on this transform, and now it's going to give us some information. There we go. So we can already stop it here. And basically here we can see the results. It says for camera bot base link to RGB camera link frame, chain is RGB camera link frame, chassis camera bot base link. Okay. The net delay is in average this. As you can see, it's an exponential, so basically this is very close to 0. So there is almost no delay. Okay, same goes for the maximum delay, which is it's very small. It's a very this is a number very close to 0. Okay, but what happens if instead of this transform we check the delay for the transform that we are publishing, which is this one, right? So we are going to check the delay. Let me readjust here the terminal. From the world frame to camera bot base link. So this is the transform that we are broadcasting, right? So let's check the delay of this transform. It's, as you can see, it's gathering data for 10 seconds. After 10 seconds, it's going to give us the results. There we go. Okay. So, results. For world to camera bot base link, the chain is world camera bot base link, and the delay in average is 0.01, and in maximum is 0.1. So this is a lot, right? Well, it's not a lot, of course, but if we compare the results of the transform that we are publishing with the results of this transform, which is almost 0, this is a lot. Yeah, this is 0.16 seconds. So, so it's a lot. Then why this is happening? Well, this is happening basically because this transform is a dynamic transform. Between other things, this transform is it's being treated as a dynamic transform, while this other transform it's a static transform. So it's much more fast. Okay. However, I'm not going to go into details because it would be too much. Then, yeah, so in the results you are going to see that our the transform that we are publishing, it has a delay much higher than the others. So, yeah, so this is because they are static transforms or behave as static. Okay, so in reality, this delay that we are seeing there is practically null. As I have said, that number is basically 0. Okay. In our case, it's much higher, right? And it's it's not. Maybe you don't have the same numbers here as in the notebooks, but you are going to see that this delay is much higher than in the first test, right? Then basically, this delay, let's say that it's not acceptable by RVs. Okay, and this is causing some errors, like these messages here. Okay, and among other things, this is causing the error of not being able to visualize the camera image. Okay, so in order to fix this, basically, what we are going to do is to change the timestamp at which we are publishing the transform, okay? So we are going to use the same odometry time, the same timestamp of the sensor, okay? So if we have a look here at our code, at the initial code, we are going to see that the timestamp that we are using here is the clock now. So we are accessing to the current time, and then we are using this as a timestamp, okay? So we are going to change this, and instead of this, we are going to use the timestamp of the odometry message. Yeah? So let's come here, and we are going to create a separate script here. So let's go back again here to the terminal, and here we are going to create a new Python script here with a touch command. There we go. We are going to again give it execution permissions. Okay. And now we are going to copy again the code from here. You have it again in the notebook. So let's copy it from the notebook, and we are going to paste it here into the new script that I have just created. I have it here. Okay. So now if we have a look at this new script, let me maximize it here. If we have a look at this new script, as you can see, now we are using the timestamp of the odometry message, okay? So we have modified here the get odom data, and now, besides the position and orientation values, I'm also getting the time header. Well, I'm getting the header of the message, which inside contains the time, okay? Then I am using this header, specifically the time of the header, the stamp, in order to broadcast my TF, as you can see. Yeah? So I am no longer getting the current time, but I am using the time of the odometry message. All right? So once again, let's install our script by adding the new Python script to our CMake lists. So you have also here the line that you have to add. So let me open the CMake lists and add here the new script. And once again, I'm going to compile. There we go. Colcom build symlink install. So let me come here and compile my workspace. There we go. Source, as always. And then finally, I'm going to run my new script that I have just created, okay? So, yeah, so then let me stop this one here. Let me stop RVs also, stop the original script, and now I'm going to run my new script. There we go. Okay, and now I'm going to open one more time RVs. Let's see what we get now in RVs. Okay, excellent. So now we can see the images, right? Now we have access to the images of the camera bot. So we have fixed this initial issue, and also you are going to see that in RVs you are not getting anymore this message. Okay, well, you might get some message of a specific message being dropped, okay? But it's much better than before, which we were getting we were dropping messages constantly, right? All right, excellent. So yeah, so now, for instance, we can check again if we want with the TF2 monitor the delay. So let's do it. Here, for instance, where I am not running anything, I'm going to run again the TF2 monitor to check the delay from world to camera bot baselink, to check the delay that I get now from my transform. Let's see. Okay, there we go. So now, for world to camera bot base link, the average delay is a very big exponential, so which this is basically equivalent to 0. Okay, so yeah, we have reduced drastically the delay. So this is why we are not getting these messages anymore. We are not dropping messages, and we are able to visualize the camera. So as a final test, what we can do now is to move again we can move the camera bot one more time. Let me do it here. I'm going to start moving here the camera bot forward. There we go. Here we can see it moving forward. And now in RVs, I'm going to see how the transform is being updated dynamically, right? So as I get far away from the turtle, I am also seeing the TF getting updated here, right? All right, so let me stop the robot. There we go. Okay, so yeah, great. So basically that's it. We have finished. Of course, there are still some things to be solved here, right? So yeah, so we can also rotate the camera. Let me try it here to rotate a little bit the camera, and we should see as well here how the TFs are rotating, right? So so yeah, there are still some things to be fixed here, of course, especially in relation with the 3D turtle. Okay, so we should connect the turtle to the world frame in some way. But for that, probably we should use static transforms, and we are not going to be covering this in this open class, okay? So as I already said in the beginning of the class, in case that you want to keep learning more and see how to fully solve this exercise, you have much more details in the complete TF for ROS2 course here in our academy, okay? So yeah, for this class, I'm going to leave it here. So let me already stop everything that I am running here. Let me know here in the chat if you have any questions, comments before I close. So now is the time. If you have doubts, questions, whatever, it's now or never. In fact, I'm going to already switch here to my screen. All right. So yeah, I don't see any comments, any questions. So hopefully this is because you have understood everything perfectly. So yeah, then let me close it and finish it here, saying that thanks a lot for being here with me during this hour, during this new open class. I hope that you enjoyed the class, that you have learned something. And yeah, I'm going to see you again next Tuesday with the next open class. Until then, as always, keep pushing your ROS2 learning. Bye-bye.